I'm going to go through some of the key detail about data center and cooling for data center. So certainly we are experiencing a revolution on the data center, and in particular on the data center connected to AI and cooling for AI. So we at Schneider are certainly working on the data center since ever, and the possibility to see the transition that is happening to normal cooling, from normal cooling to liquid cooling, as well as the other challenges that any of us are required to address in the next coming years. So yeah, I was saying we have three major challenges that we need to address when we talk about the liquid, when we talk about cooling for data centers. Certainly, the evolution from air to liquid cooling and the densification that is happening on data center. That's absolutely one point, as well as the sustainability and the decarbonization topic. This is a data center, as you know, and in particular for cooling for data center, are one of the worst or the most critical application on the energy perspective. Before the pandemic, air transportation was primarily driving our sustainability effort. And right now, globally, the data center are the most impacting our life issues on that. And last but not least, how much the new refrigerant, the recent F-gas, and the next incoming PFAS is going to change the way we are designing data centers. So, of course, at Schneider, we have the complete portfolio. We would like to be to design cooling for data center, assist you on that with high quality, resilient, and sustainable cooling. However, the key point for us is to offer an end-to-end approach. So we see that in particular, the evolution to liquid cooling and the evolution to the next sustainable challenges is not anymore a game that a cooling company or any other operator can do alone. These are challenges that all the ecosystem, the data center ecosystem, need to take care together. So we should work together with the contractor, specifier, consultant, advisors, and the other cooling companies, and to design the best data center and the most effective data center. It is not anymore a game which can be won by a single player in the market. It is a community that need to win the challenges together. So that's why I'd love to have this conversation and many other conversations with you guys to create a community which can sustain the evolution on to better data center design. With a very wide portfolio, again, cooling, unfortunately, is not an easy stuff. There is not a product which fit at all, and using that product, all the solutions are addressed. A wide cooling portfolio is required. We will learn that the new standard and the new requirement, for example, on refrigerant, will also move this portfolio even wider with different solutions by country. In particular, Europe is playing a different game than other countries globally. So we need to have a wide portfolio, and we need to act together as a community to identify which one of these portions of the portfolio are the best for the specific application. On air or water or liquid, all of those are very important to be addressed together. Because when we look at a global footprint, we need to serve these from our global factories. But when we look at this global footprint, there are different ways to design a data center. There is something based on chilled water. on refrigerant or air. So if we can try to oversimplify from A to Z the possible different solution, of course, there are many of those. There are multiple with pros and cons, but we can oversimplify saying that one is on chilled water or on direct expansion or on centralized air handling unit. More in general, what we are capturing right now is that the larger the data center are, which is something that is happening in the market, the AI, the densification, and the higher requirements of digital services are moving on cloud and extra large data center in the cloud. All of those are moving more on the chilled water unit with perimeter or with fan wall or with CRA. That's something that is more in line with the densification, but also in line with two things. Point number one, removing the refrigerant from the equation or from the white space. The refrigerant-based system or the centralized air handling unit have contact between the white space air and the refrigerant. And unfortunately, the new refrigerant are slightly flammable. So on the design perspective, on the engineering perspective, the flammable, although slightly flammable, refrigerant open new challenges on how to design a data center. So size is driving chilled water, refrigerant is driving chilled water, but also liquid. Although a data center is not designed for liquid, it might be designed for liquid. And that's why what we are capturing, despite the portfolio is very wide and we are available to provide any of those, the chilled water, perimeter, fan wall are the most used in the data center and in the cloud service provider. So the flexibility and the no refrigerant in the white space are driving this. Of course, the edge approach is still using refrigerant-based units, in particular with in-row units. However, the centralized air handling unit and the refrigerant-based unit are in this moment experiencing more challenges because of the refrigerant or because of the liquid cooling than chilled water. So more in general, a comment is that the chilled water are more in line. And of course, despite any of those solutions have pros and cons, there is unfortunately not a solution which is the best at all, regardless the application, the location, and the usage. There are plenty of pros and cons by application. However, again, the challenges we are all together called to define and to solve on efficiency, on sustainability, on no waste water, on no waste water usage are moving the design for any sizes more on chilled water connected to either underfloor air conditioning units or perimeter units or fan wall, which are the solution where the capacities are even larger for that. So these are the scenarios we are capturing right now and where we are acting, in particular because we need to be sustainable. And again, there is not a single action we need to do for being sustainable or creating a sustainable data center. Of course, scope 3 is primarily impacting the energy use. A cooling unit, a chiller, if you look at the environmental passport for a chiller, the life cycle assessment for a chiller in a data center application, 90% of the energy on the sustainability impact is connected to the phase use, to the scope 3. because it uses a massive quantity of energy. However, minimizing the energy use cover only one portion, is only one angle we have in looking how we can be more sustainable. The refrigerants are certainly another one. The no use of water in the data center. Many times people are mentioning waterless data center. For us, waterless data center means no waste water. So no adiabatic. We have adiabatic in the system, but the usage of the massive use of water that adiabatic requires is not in line with what the European conditions are. I mean, today in LA it is raining a lot, but we spent all of the winter in dry situation with no rain, with the river at very low level, and that's not only Italy; it is all Europe that is experiencing the same. So we should not be dependent on water, which does not mean to not use water inside the pipers, of course. And that's the most important. We should not look at only a single portion of the equation, but we need to look at the implication of all the action we are doing to have a sustainable data center. So minimize energy use, definitely. We need to reduce the energy consumption, to use free cooling as more as we can, leverage on high temperature, design a data center according to the ASHRAE recommendation, 27 degrees C discharge at minimum, 22, 23 degrees C at the chiller side. Try to have district heating as for the previous conversation you had in this event, and try to move to liquid cooling, to not use new refrigerant, migrate to new refrigerant, use natural refrigerant if they have the same level of efficiency of a synthetic refrigerant, not use natural just because it is cool to use something natural. It is important to consider also the energy perspective. No water dependency. Okay, that's fine. But if you use water just to overcome the peak temperature, it might be considered an opportunity end-to-end for an end-to-end saving. So those are some best practices we can say on designing a carbon neutral data center, or at least a sustainable data center, with a specific action on greenhouses. We know that the F-gas has been released back in March this year. This is going to not change completely the market because many players already migrated to new refrigerants. But the good thing of this F-gas is that it is very in line with also what the Environmental Protection Agency in the United States is saying, more or less the same period. So both Europe and the United States are migrating away from the high GWP refrigerants. So 1234Z, the 513 are something that are common and widely used. These new standards are going to be even more important to accelerate the transition to the new refrigerants. We can say that Schneider is ready. Many players are ready on the chiller. The challenge is the new refrigerant inside the white space, because they are, although slightly flammable, they are flammable. So again, this is something that in our experience shows more people designing a data center with chilled water than refrigerant based. And then there is the next to come, which is the PFAS. We are discussing about PFAS since many years. Right now, there are expected evolution on that, which will force people to migrate to natural. But the big question about natural refrigerant is if they are at the same level of efficiency of the synthetic refrigerant or not. because using natural refrigerants, just because they are natural, with a lower level of efficiency, it is greenwashing. It is not real efficiency. So we need to be pretty robust in accepting, be compliant with the new standard, but not accept those just because it is, again, cool to have natural. We need to be, and all the industry need to migrate to a new generation of refrigerant when the technology is ready to get at least the same level of efficiency that they have right now. But the fact that is going to, the F-gas is in place, so synthetic refrigerant will lodge the WE is going to happen. My personal recommendation, despite the revolution is, the evolution is moving to a limit, in particular for large equipment, around 750 for chillers in particular as GWP. Our personal recommendation is not consider these as the best in class. 750 allowed to have 513 refrigerant, for example, 515 refrigerant, for example, but also 1234ZE. 1234ZE has a very good efficiency and a GWP of 7. So despite 513, 515 are compliant with the new F-gas, we strongly encourage all of you to consider ZE as a possible solution, despite the other comply with the F-gas, because these will be a real step, a real leap in to be more efficient and more sustainable for data center. And then, of course, this is valid for any data center, but we know that the densification is happening. The request that all of us has on digital service is increasing the density, and liquid cooling is coming, or is already here. What is the real dead end of air cooling? That's a big question. What, on the technology perspective, we can say that you can cool with the air even more than 50 kilowatts per rack. However, the most recent ASHRAE recommendation, in particular the H1 envelope released by ASHRAE back in 2020, says that more than 50 kilowatts per rack requires a supply air temperature between 21 and 24 degrees C versus the usual 27 in the recommended envelope. These make possible to cool with air cooling, but completely not efficient. So it is a different angle we need to use. So despite the technology can do this, 50 is the dead end of air. More than 50, we need to use absolutely liquid cooling. Less than that, that's liquid is possible. It is a fantastic opportunity to be more sustainable. However, it is complicated because liquid is at the beginning of its journey. Again, it's important to be clear on the messages. Many times people say liquid cooling is the only way to be sustainable. That's partially true. Liquid cooling is a great way to be sustainable for the current densities. For more than 50 kilowatt per rack is the only way to cool a server. So again, saying that sustainability is allowed by liquid is a partially greenwashing message. It is very, very true with low density. It is not true with high density. High densities requires liquid, period. That's the only choice. How a data center with liquid is designed with. So again, liquid cooling is not a product. Liquid cooling is an architecture. And again, all the ecosystem, all the cooling community in the data center business need to react on that, considering what it is in the server. That's fine. Is liquid cooling server. There are server manufacturers that are providing embedded technology over there. But there is everything else, the cooling distribution unit, the complementary air cooling, which remain in the equation, the heat rejection unit, which need to be combined together in order to optimize the data center. So again, it's an architecture that use multiple different bits and pieces on that. So that's an example how not complicated but broad is the choices for the best heat rejection unit, the best cooling distribution units, and the best solution in the white space. There are none of those are applicable everywhere or are perfect everywhere or for every application. The best solution need to be addressed by location, by application. For example, in hybrid data center is very good with cold plate connected to a in-room cooling distribution unit and some complementary air cooling to dissipate the electrical portion, and all of those connected to a heat rejection unit. Which one? A dry cooler can be used, certainly it is possible, but only for low density and low climatic condition. For hot, warm zone or high density, a dry cooler is not enough. You need a chiller, or you need a free cooler compressor assisted. So the combination of these layers define the data center solution. Because again, on the white space approach, the 5 different technologies that are available today, so the direct chip, the immersion, either 2-phase or one single phase, are pros and cons by application. It is true that the first wave of liquid is single phase direct chip because it is easy to go. It does not reinvent the wheel and the layout of the data center, but all the others have pros and cons. So again, the recommendation here, and it is not possible to do in 20 minutes, of course, is to be more in contact with the players of the game and define together which is the best solution at the white space side, but also at the heat rejection side or on distribution side. So again, it is a global discussion and an end-to-end discussion that all of us need to have. And to only working together, we can define what is the best server, the best CDU, and the best outdoor heat rejection unit. On this, for example, it depends, the best solution depends if you have low densities and climate, or high densities, or different densities and different climatic zone. Which one of these, for example, are the best? It depends where you are, what you're designing for, and how you would like to address the customer requirement. So again, it's very important, the cooperation, the portfolio, and how we can work together on that. So I try to condensate from A to Z all the main points for a data center cooling infrastructure. Of course, 20 minutes is, doing this in 20 minutes is a challenge, but I'd love to get any question, any point that you may have.
Thank you so much, Maurizio. It was a challenge, but you did really well at condensing it into the short period you had to talk about it. It's a big subject to cover. We've got a couple of questions from the audience, if I can just put these to you quickly. The first is, we're really keen on reducing our carbon emissions, so we're trying to work out what cooling technology is the most efficient. Could you discuss the long-term environmental impacts of various cooling technologies? Which systems are considered most sustainable?
More in general, in a very few words, the most sustainable is high temperature chilled water solution. So chillers combined with high temperature application. How much high? Depends if you're moving on air or liquid, but let's try to have the higher water temperature to design and select a chiller designed for that, so with embedded free cooling, and use the most efficient compressor and the most efficient refrigerant you can. This is definitely the most sustainable without any adiabatic on that, except for perhaps very, very peak temperature, but the normal use should not use water. Using water to save energy is similar to clean a room, moving the dust into the carpet. That's not real sustainability.
Yeah. Thank you, Maurizio. And just one more question before I let you off the hook. Given the new F-gas regulations impacting refrigerants used in cooling systems within the EU, and considering the varying compliance dates and the phase-out schedules, it's a lot. What strategies could we use? We want to ensure both compliance with these regulations, but without sacrificing operational efficiency.
Again, the good news is that, in particular for chillers, the new low GWP synthetic refrigerant are pretty good. We know that ZE in particular, 1234 ZE in particular with turbo core compressor are more efficient than 134A. 513 is probably a good compromise when you have a screw compressor, but in general, with synthetic, the best choice is the best combination for sustainability, efficiency, and low GWP is turbo core plus ZE. The natural are perhaps good in efficiency for comfort cooling, propane, for example. But their efficiency level at the data center conditions, so in particular at high temperature, are not yet at the same level of synthetic. So there is a lot to do there. Probably in the long run, they will be part of the game. But today, the best choice for our planet is ZE and turbocore.
Fantastic. Thank you so much for joining us, Maurizio. We really appreciate your insight today. Thank you.
Thanks a lot. Thanks for the question. Have a great day.
Thank you. Bye-bye.